guys ready? Great.
Hi everybody, we are Team 2. I'm Daniel Brown. I'm joined by Caleb Yarbrough, Wayne Johnson, and Reed Matchcheck. And we're going to be going over our progress report for the detection of plastic in cotton gin modulators. Okay, so to give a brief description of our problem for those of you who don't know a lot about it, plastic contamination is a pretty big issue within the cotton industry. This is partially due to just your typical litter within the cotton field, plastic bag, water bottles, whatever it may be. But it's also increased in the last several years due to the use of the John Deere cotton stripper that produces a round bale. This round bale is wrapped in a thick plastic that can't be reused. They have to cut it off, and sometimes it can get caught in the module feeder whenever it first enters the process. In the past, a camera has been mounted on the back of the module feeder to be able to see if there's any plastic that gets wrapped up in there that enters the system. However, with our particular project, we're working with the third iron module feeder, which has 2 rows of spindles as opposed to just one, which means basically that you've got a front row of spindles that tears apart the module as it enters, and then a second row after that, instead of just having one. So that if you have just a camera in the back, you can't see anything that's happening in the front of the module feeder. You can see what happens in the back, but it isn't the most effective method. Now I'm going to switch over to Reed here, and he'll go over the next slide.
Yes, I'm Reed Matchcheck. We'll be going over project uniqueness and some vendors possible for our solution. And like Daniel said, the problem has been growing since 2009 when John Deere came out with their 7760 harvester with the round bale. John Deere did put out a recommendation on the bales called the RFID tag. So when they're placed in the module feeder, this is where John Deere recommended the module feeder to cut. And it's supposed to have less plastic going into the module feeder. But as gens were using this strategy, they realized that when it was cut at the RFID tag that was recommended, the module would actually fall apart on top of the plastic, which would then, plastic would be hidden underneath the cotton, which headed into the module feeder. And studies with the stick machine and the extractor feeder were just some other applications that gens try to use to solve this problem. And the stick machine and extractor feeder actually did very well getting out thick material from the module feeder, and the cylinder cleaner actually cleaned out 46% of small plastic material, which 1 inch by 1 inch, but then it took out less than 1% of any other floor matter bigger than that. And gens also used a strategy of slowing down the process rate of the gin just to sift out the plastic better. They realized by slowing down the processing rate, they were decreasing fiber strength and quality. And you can go to, and these are some of the vendors that you could possibly buy, like equipment for our solution. So the lights that are going into the module feeder, cameras, bolts, fittings, any type of construction or hardware that is going to be used to put up this system in the module feeder. Most of these can be found at local hardware store or at the gym co-op maybe. You can even find this type of stuff on Amazon or any type of online purchasing website or stuff like that.
So. Good morning. As Daniel said, my name is Caleb Yarbrough, and I'm going to be going over some of the regulations that are going to be applicable to this specific problem. So first of all, I want to cover some of the OSHA safety regulations. In a memo that has been made publicly available by OSHA, they answered the question that Title II, Part 1928 of the Code of Federal Regulations is applicable to cotton gin operations. Particularly, subsection 21 is a general industry safety standard that applies to any kind of construction or electronics that happens in a normal gin operation. Specifically, subsection 57 is the one that actually has cotton gins in the standard itself. It has to do with physical barriers and safety guards on moving parts, machinery, walkways, elevated walkways. That is the overall safety guard regulation that sets forth in that standard. Anything that is not expressly covered in those two standards falls under Section 5A1, commonly known as the General Duty Clause of the OSHA. I said it has to be applied when Part 1928 does not expressly apply to that hazard or that risk. Next, EPA air quality regulations, and this is a huge impact on cotton gins. They fall under the NAAQS, which is the National Ambient Air Quality Standards. That dictates PM standards, PM 2.5 and PM 10 that a gin must remain compliant with, otherwise they'll lose their permit and won't be able to operate. Specifically, the Clean Air Act regulates PM 2.5 emissions PM 10 emissions to 150 micrograms per cubic meter and PM 2.5 emissions to 65 micrograms per cubic meter, respectively. One thing that the team is going to have to remain cognizant of is our implementation and our design of our final solution is going to have to not increase air pollution, so that not only we can maintain a safe environment for the employees, but also that we can remain in compliance with the EPA and that the gin can operate efficiently and remain operating as normal operations. Some of the current industry practices that we've seen, the USDA Agricultural Research Service, in conjunction with the ASABE, is developing a new cotton wrap standard. They're starting to move towards a thicker multi-layer wrap because they found that this is a lot easier to eject once it gets into a cotton gin or into flowing seed cotton. There's a machine that the Las Cruces, New Mexico Gin Lab has purchased called a Golden Line. It's available from a Chinese company, and it's a passive detection and ejection system that uses mechanical and pneumatic impulses. So it blows cotton with the associated plastic contamination into the machine, and theoretically the plastic would stick to the internal drum and separate from the cotton, and the cotton would blow through. It works really well for larger pieces. However, the test lab was having some problems. The machine was advertised as 80% effective. They found it to be closer to 60%, and they were able to determine this was due to the air impulses simply weren't strong enough. So after some modifications to increase the air input and the airflow, they were able to get closer to that original effectiveness as advertised. Finally, the ARS is developing a color detection system, and this system actually operates within the gin itself. So in the seed cotton flowing through, it detects colors like pink, blue, and yellow, standard gin wrap colors. And once it detects that color in the flowing seed cotton, it fires a solenoid which injects an air impulse into that seed cotton and blows the large contaminants and the plastic out of the system. And they be the most effective at 90%.
Good morning. My name is Wayne. Like Daniel mentioned earlier, I'll be going over 3 publications, published reports for our literature review. The first 2 are basically reports over tests that have been conducted in conjunction with our very own Greg Holt, part of the client from USDA-ARS. The first 2 are about the use of cameras and the camera detection system to be able to detect the plastic inside the module feeder. The third is another one that involves IMS technology, and I'll go over that when I get there. The first published report is called the Cotton Module Feeder Plastic Contamination Inspection System. In that report, there are 2 proposed systems. The first of which is the simple system, is basically using disposable cameras. There's a housing that covers those cameras that can shoot a blast of air to clear debris in front of the camera to make sure you can remain to get a clear image. It also utilizes the GIN's cameras. This system is basically a part of the GIN crew is going to be watching a live feed of what that camera can see, and then they have to manually stop the module feeder and try to clean the plastic contamination out. The second of which, like it says, augments the simple system, where instead of someone in the GIN crew having to manually stop the system, it uses a PLC and then a software that's developed excuse me, by those that are researching this to automatically pause the module feed so they can clear it out so they don't have to have so much of an attentive eye on a feed to stop it. Like Daniel mentioned earlier, the issue that we face with this is that this system is tested on module feeders that only have one row of spikes. So part of the issue is that we won't be able to see everything that goes on with between the two spikes, two rows of spikes, not on the front row. But in theory, what we would want to do is find a way to implement this system into the third arm module feeder. This report here, a plastic contamination image data set for deep learning model development and training, is a follow-up to the previous report. So this goes more into depth about how that camera system automatically detects plastic contamination in the cotton. What it does is the cameras take images of the cotton as it's feeding through. Of course, it has the plastic pieces that are in it, and someone took those images and they highlight in boundaries of different colors. So red would be the cotton, if there's cotton in that image. Yellow would be reflection of the metal that the cotton is moving on, and then purple would be the plastic contamination. And what it does is taking this set of images and applying it to like an AI system so that it can continue to be able to figure out on its own what a piece of plastic contamination would look like in the cotton, so that we can continue to be able to do this without the taking more images. Part of the specifics of this is that for the system, you have to specify what type of sensor was used, to specify the camera, specify the lighting, so that you can be able to replicate the results. Limitations of this system currently are that the camera has trouble detecting white or black plastic. Daniel mentioned earlier that part of the contamination doesn't come from the the bale route so much as it comes from just litter in the field. So white plastic bags, grocery bags that get littered into the air outside that end up in the cotton field. Of course, because of the same color as the cotton, this system has difficulty detecting those. And also black as well, because it reflects the same way and it also can look white to the camera. So it also has an issue detecting black plastic. And the system also has a trouble differentiating plastic from degraded cotton. So this is cotton that has become like yellow spotted because it isn't as pure. So the next level of detection that this report wants to move to, or would like someone else to advance the research on, is being able to get away from detecting colors as much as detecting textures of different materials. So it'd be easier to not miss those white or black pieces of plastic. Lastly, this report, laboratory detection of plastics in seed cotton with ion mobility spectrometry. That's that IMS that I mentioned earlier. IMS technology is primarily utilized for defense and security measures. So this is like when soldiers in the military have to go somewhere and they're not sure what might be in the air or if there might be any substances in the building that they're about to go into. This is also like the airport. Anytime police have to do a raid or some sort. Just a way of being able to figure out what's behind something, what's in something. But it also can be used to detect plastic in the cotton gin. It was tested by Paul Funk and others at a lab out in New Mexico. And they were able to get plastic detected in a lab setting, but there currently aren't any commercial gin applications for it yet. Basically what that IMS does, I'll explain it really quick, is when the cotton is heated, or rather when any material is heated, it gives off vapors, and then ion mobility spectrometer, it can read the speed at which those vapors are moving, and then that's how you are able to identify what the material is. So this is a much more advanced system. Like I said before, in theory, we would want to apply the camera system since it's already been in development by someone who's part of our client group. But this is just another option that we may be able to go with because it would save us those issues of detecting different colors as well. Two vendors that are mentioned in that New Mexico report, Smith's Detection and Psionics Corp. That report was written in 2008, like you see at the bottom. So Smith's Detection seems to have moved kind of away from cotton and agriculture and just more towards, defense and security. It still uses IMS technology, so it maybe could be applied to the cotton gin still, but they're not in active development of it that way. And then Sinex Corp, I wasn't able to find any more information about them except for that they were mentioned in that report. So I don't know if they've disillusioned or anything like that.
So in conclusion, we'll be looking into off-the-shelf items for this project, as well as we'll be working with the agricultural engineering team that's also working on this project to, if we need to, develop a completely new item to be used. Our next progress report will be on February 23rd, approximately 3 weeks, actually exactly 3 weeks from today. We'll talk about our potential solutions that we've come up with, as well as how we analyze those solutions. And before that meeting, we'll have a meeting with our faculty advisor. Does anybody have any questions?
Let's go with the client first, please.
So I heard a lot about your research. Have you guys identified any, I guess, strategies for what you're going to do different on this type of feeder versus the things that have already been done?
Did you say that again?
Have you guys? I guess maybe I missed it, but have you guys been thinking in terms of strategies for this specific application? I mean, I heard a lot of literature review and things that are being done, but have you guys, I guess, got some 30,000 foot kind of strategies going on or ideas that things you're gonna be looking at?
So far, this has just been preliminary research to make sure we understand what has already been done, so that whenever we get to start designing something, we're not reinventing the wheel.
Sure. Yeah.
Basically, what we've been doing is making sure we understand what's already available, especially since these reports are so recent. Those were tested in, they were tested in gins in the 18 and 19 season, and that report was written last spring. So we want to make sure we're current on what's available before we begin. But we've done some small brainstorming on what we might be able to do to get around the 2 sets of spikes, but nothing official as of this report today.
No, good answer.
I just say we feel like the best method obviously is going to involve multiple security cameras. We're just trying to determine what would be the best way to arrange and set them up, and also protect them from the environment that it's going to be working in.
Yeah. Thank you.
You're welcome. Sure.
Okay, let's have Team 1 give a couple of comments, and then Team 9 we'll let you make some comments. So Team 1 just reviewed the other team, right? Okay, got it. All right, Team 9, over to you.
So my first, I guess, comment kind of question was on the same as Kelly's, is making sure that I said surely that this problem isn't brand new, and I think that there's probably some similar products already out there. So I know they're not quite to the design phase yet, but just really making sure that what they're going to recommend is going to be able to differentiate themselves from what is already existing as a problem.
Anything else from Team 9?
I'd say for y'all solution, what percentage of plastic reduction?
Shooting for 100.
Yeah, there's not.
At least like 65 or 70.
I'm sorry. Okay. So you said what are we shooting for?
What percentage would y'all be shooting for plastic reduction?
Okay, so to repeat the question, he asked what percentage are we shooting for plastic reduction? As far as my understanding of the problem, we aren't necessarily trying to reduce the plastic. We're just trying to detect it. Like Our product is not going to be something that removes plastic from the system. It just says that there is plastic there.
I'll give two things on that if we have time. So one, there isn't necessarily an allowable limit set by a regulation for plastic contamination. It's just that any amount of plastic that gets in there, first, if you don't catch it in the module feeder, it has to remain in there through the rest of the value added processes. So you don't see it again until the finished product, which drastically reduces how much money you can earn from selling it. So we really don't want any to be in there if we can prevent it. And also, and this goes along with choosing something that's manual or automatic. In that report that I talked about in the lit review, it basically mentions that the gen crew has been pretty good at pulling out plastic once the module feeder is stopped and once plastic has been detected. So that's our goal, is to be able to find a way to see it as quickly as possible, get the feeder stopped, get it pulled out, and get running again. So that's right.
Okay, I think that's sufficient. Why don't we ask Dr. Hart, do you have any comments, questions?
Unmute. Okay. Hi. Yeah. So I was going to make a comment. I think I noticed during your presentation you were talking about the proposed ASAB standard, and I think you said that it was for making the wrap thicker. Did I hear that right?
Having luck with working with thicker wraps and getting more of it out of the system. The thicker the wrap, the easier it is to, once they detect it, to get it out of the system. A lot of thinner wraps, they're a lot more liable to stay in the system.
Well, that's not quite correct in the sense that the standard, one, it's really voluntary, and the current wraps that are sold would meet the standard. You know, they would be allowed. It's really kind of driven because the patents for that are expiring, so other companies can come in, and we've seen some of this. I don't know if Mr. Green shared any pictures where some very low cost wraps came in that really weren't suitable. So that's kind of the idea there, is that, you know, we're not going to make it any thicker just because there'd be it'd be too costly probably. So we kind of, we have to work with what we have.
Right. Dr. Castell, you want to, you have some questions or comments?
Mostly comments. I really enjoyed the explanation of the problem. It's like attempts to fix the problem and how they fail. It was very, make it clear to me what you're dealing with. And I also like that you address regulations. I was wondering why, when you were about equality, but fail, then you answered the question yourself. So it was very well organized. And I really appreciate that you look at out there technologies like AI and IMS, even though you might end up dealing with the cameras. I really appreciate that you have looked at other options that might make it unique, as you say, in the future. So again, I would have liked to see a figure on the feeder and some plastic issues that help. But overall, I thought it was very well organized, and I don't have any questions now, but for a preliminary presentation, I thought you did a very good job explaining the problem and what it's done.
Yeah, I agree. This was a really nice presentation. I wrote down things like your slides, your organization, the actual staging, the moving back and forth was very well done. It looked like you rehearsed it. The only thing I'm counting off on your presentation is the lack of pictures and figures. You know, we're Aggies, so we like to see pictures. Okay. It's a bit of a, you know, it's kind of like, why do I need to show my client a picture of a module feeder? He knows what it is. Yeah, I get that, but go ahead and show pictures anyway, particularly as you're going to get into what the problems are. You know, you need to do that. So that's really my biggest critique, is just I don't think there was a single picture in the whole presentation, so I expect to see more next time. Yes, sir. All right, your timing, 16 minutes, real good, very equally distributed. Reed, you came in a little short, but that's okay. Project description, Daniel, was really good, very well detailed. Reed, I thought your discussion of project uniqueness was good. Caleb, regulations, fantastic. At first I wrote down, why are you talking about the NAAQS and the Clean Air Act? What does air quality have to do with removing cotton? But you kind of answered that question when you said, well, we've got to keep this in mind because any solution we present can't contribute to more air pollution. So I'll allow it, okay? I thought that was good. Go to that slide about current industry practices. There was something I wrote down here and I don't know what it was. Okay, the second bullet doesn't really tell me what the practice is. It just says the Gen Lab has been working with a Golden Lion machine. It uses a combination of mechanical devices and pneumatic impulses. I'm assuming it means to remove plastic, but you don't really say that. Although you did describe it that they send a pneumatic impulse across. So I felt like this was a little too. I'm really having to work hard to critique you. Okay, so that could have been worded a little clearly.
I might say that the title, a better title for that slide might be better, because obviously the Golden Lion's not current industry practice, and the ARS color detection system's commercial, but it's just been introduced, so it's maybe possible solutions.
Okay. Yes. And then Wayne, literature review. Wow. Really well done. That's exactly what I was looking for, except no pictures. You have one slide for each one of those very scholarly articles. Let's see. I'm going to nitpick a little bit here on your second one. Go to your second literature review slide. Now here, a plastic contamination image data set. And I looked at the word data set and I'm thinking there's some data. Maybe there's some tables. I wonder if Wayne's going to show me any tables like and you even in your question and answer, you mentioned there were some spikes. This would have been a good place to show where the spikes were. So when you do literature, you just don't talk about what it says. Talk about what important things you're extracting from this. For example, if the data shows that there are spikes here and here in the process, then you can kind of say, so this is going to cause us to focus our potential solutions on this part of the process. Okay. So the literature review isn't just for academics, it's to teach you, it's to inform you where the problems are. But really nicely done. Go to your next slide. I'm going to nitpick here a little bit. It took me a little bit to figure out what IMS stood for. I'm using that term like in school, and I had to study the title. Ion Metro Mobility. IMS. So when you use an acronym, make sure you clearly define it and for your audience. Good use of technical papers. And the only thing else I'm going to ding you, Wayne, is you have your hand in your pockets a couple of times, and that's usually not considered good form. Okay. Good job. Jan, do you have any comments? I'm sorry I've been ignoring you, but you've got some things to say too. Okay. All right. Okay. Well, we're almost out of time. Let me say a couple of administrative things to everybody who's on Zoom and here in the room. So there's some things due now. The first thing that's due is your what do we call that? The peer review form. Okay, Jan, you have instructions about that. They submit that on eCampus, right? Yes, sir. So submit your peer review form to Jan or to us on eCampus. You'll get credit for that. That's an easy 50 points. 2 comments, 2 questions, or any combination like that. Secondly, download the form for what do you call it? Self-critique. So before your next presentation, you actually need to go to our page and find your presentation and watch it, and then critique yourself and write your critique on a form, and you're going to submit that for a score also. So I'll be asking you next time, what did you learn from your self-critique? Main's going to say, yep, I put my hands in my pockets. I'm not going to do that. So those 2 things are due. verbally, I'm going to say, I'm assuming because you picked these projects that you're interested in the cotton industry to some degree. There's a scholarship application out there, Free Wildman Scholarship. National Cotton Council awards multiple throughout the year. If you're interested in that, let me know and I'll send you the application. They're due right away. It's been out. And so they really like to give scholarships to students here from state and because historically we've had a lot of interest. So if you're interested in working in the cotton industry, and I assume you may be because you're on this project, then you might be eligible for scholarships. So let me know. Okay? I'll tell you what, I'll just send you the applications and you can go through the trouble of filing it. Yeah. Okay. Mr. Green, any final comments before we sign up?
No, thank you guys. Those are great presentations, and I look forward to hearing what you guys have in a couple of weeks.
Yeah, we're off to a good start. We're a little bit, at the next presentation, we're going to get into potential solutions. The purpose of this was just to kind of set a baseline of what's going on, define the problem, research the problem, and now they're going to make an informed decision on some potential solutions.
I will say if you guys are interested in our internship, that's I think Aaron's going to be talking about that tonight, right?
That's right. There's an access to the meeting tonight, and an internship could be in your future this summer. You guys would all be safe for that. Anything else, Elena? No. Okay. No? Good. All right. Why don't we? Any other questions from the floor? Comments? Well, thank y'all for being the first team up to bat. You both did a great job, and I'll bring better presentations next time.